All right. So we have another new question here, and we're told that the angular position is stated as theta, or you can call it the number of revolution, or you can call it angular displacement. We are told that the angular position of a 0.48 diameter. In the question, we're given our diameter to be 0.48. And don't forget, radius is half of a diameter. Definitely, you can get our radius from here. That means our r is equal to d over 2, which is 0.48 divided by 2. So 0.48 divided by 2. So it's going to give us 0.24. 0.24 what? Meter. So, and we're given our theta. It's more like an equation to be 4 rad per second cube. Then t what? T cube. And in the question number 1, we're asked to find what theta. So we have to look for our theta at t1 equals to 3 seconds and t2 equals to 6 seconds. So we also asked to look for the distance. Distance is stated as x. So we are looking for our s in the number 2 question, okay, between the time interval. And the next one, we are also asked to look for what? The average angular velocity. That is WAVG. So the next one, we are asked to look for the what? The instantaneous angular what? Velocity. Okay. All right. How do we go about this? And don't forget, we're asked to leave our answer in radian and in what? In revolution. All right. Now, in radian and in degree, sorry. How do we go about that? It's very easy. Now, you are already given your theta, and you are asked to look for theta. Okay, how do you go about that? You are going to go about it like this. At t, for the number 1 question, at t equals to 3 seconds, I was giving my theta to be 4 rad per second cube, then t cube. It's stating as theta 1 equals to, this is stating as 4 rad, then all over second cube, then times, what's our time? Our time is what? 3 seconds. 3 seconds raised to the power of what? Power 3. So our theta 1 is going to give us 4 rad over second cube, then time, this is sitting at 3 cube times seconds cube. So our theta 1 is going to give us 4 rad over second cube, then times 3 cube is sitting as 27. Then 27 second what? Cube. Second cube can cancel out second cube. So we'll be left with theta 1 equals to 4 times 27. So it's going to give us 108. And we are left with what? With rad. So that is our answer there. So we are also asked to convert it to be in what? We are asked to convert it to be in what? In degree. It's already in rad, yeah? Now this time around, we got our theta 1 to be 108 rad because we are still going to need this. Okay, so to convert to degree is very easy. I've told you before, whenever you are converting from radian to degree, okay, you multiply by 360 and divide by 2 pi. That is, our theta 1 is going to give us 108 times 360, then divided by 2 pi. So theta 1 is going to give us 108 times 360. It gives us 38880. 2 pi, which is 2 times 3.142. That is 38880 divided by 6.284. So theta 1 is going to give us 6.284, which is 6187 degree. So that is our answer. So we can move straight to the next question. We are not done with question 1 yet. We've only succeeded. We have to find theta in radian and in degree at t equals to 3 seconds. We've only succeeded in calculating when t was 3 seconds. We also look for it when t was 6 seconds. All right. So this time around, at t equals to 6 seconds. So we have theta equals to 4 rad per second cube, then t cube. So theta, that's theta 2, which should now give us 4 rad. Pi is sitting as divide, 3 seconds, times 3 there. What's our time? Our time is 6 seconds, raised to the power of 3. Our theta 2 becomes 4 rad per second cube times 6 cube and second cube. Because everything inside the bracket is raising towards to 3. So from there, theta 2 is going to give us 4 rad over second cube, then times 6 cube is going to give us 216 second cube. Second cube can cancel out second cube. So we are left with theta 2 equals to 4 times 216. So it's going to give us 864 rad. So we've only succeeded in calculating it in rad. We have to convert to degree, multiply by 360 and divide by 2 pi. Now to calculate theta 2 in degree, it becomes 864 then times 360 then divided by 2 pi. So theta 2 becomes 864 times 360. It's going to give us 311040 divided by 2 pi, sitting at 6.284. Don't forget, pi is 3.142. 2 times 3.142 give us 6.284. So if we divide, so our theta 2 is going to give us 49.7 degree. So that is our answer for the number 1 question. So we've only succeeded in getting number 1. The next phase now is to move down to the number 2 question. All right. Now for the number 2 question, the big part of it, number 2. And in the number 2, we are asked to look for what? The distance, okay, that a particle on the flywheel ring moves over the time interval from t1 equals to 3 and t2 equals to this, okay. All right, in our theta 2, just now we got 864 rad because we're going to need this. Now this time I have to get our distance s. In my previous video, I told you that distance is equals to theta arrow. So this time around, our distance is going to be changing theta, then arrow. Why am I making use of changing theta? Is because of the time interval. At t1 equals to this and t2 equals to this. At t1 equals to 3 seconds, we got 108. And at t2 equals to 6 seconds, we got what? 864. So this time around, our distance is going to be theta 2 minus theta 1, then times what? Radius. So our distance is going to be 864 minus 108. Then our radius is going to be 0.24. So our distance is going to give, or if we subtract this, 864 minus 108 is going to give us 756 times 0.24. So distance is going to give us 181.44 meter. So that's our distance. So the next one, which is number 3 question, we're asked to look for the average angular velocity in rad per seconds and in rev per minute. All right. Now, interesting. I can wipe this. Okay, make sure you watch this video to the end for better understanding. Thank you, and don't forget to hit the subscribe button. Watch, comment, and share. All right, now for the number 3 question, we're asked to find the average angular velocity, that is WAVG. In my previous video, I gave you the formula for it, which is theta 2 minus theta 1, then all over T2 minus T1. So from here, our theta 2 is 18 as 864 minus theta 1 is 18 as 108. Then all over T2 is 18 as 6 minus 3. So our WAVG is going to give us 864 minus 108, which is 756, then all over 3. So this time around, our answer is going to give us 252. Okay, 252 watts rad per seconds. Now this time around, we were asked to convert this to be in what? Rev per minute. How do you convert from rad per seconds to rev per minute? Don't forget, let me just throw a little more light. In my previous video, I told you, if for example you are given 2 rev per seconds, you are asked to convert to what? Or let's say 2 rev per minute. You are asked to convert to what? Rad per seconds. What did I say you do? You multiply by 2 pi and divide by what? 360. Okay, minute is 60. So this time around, whenever you are giving something like this, what do? You multiply by 360 and divide by what? Sorry, you multiply by what? By 60. A minute is 60. Okay, and divide by what? By 2 pi. All right, in converting to rev per minute, our WAVG is going to give us 252 times 60, which is the minute, then all over 2 pi. So it's going to give us 252 times 60. So we give us 15120 divided by 6.284. So our answer there is going to give us 2406.11 rev per minute. So that is our answer. So then for the number 4 question, we're asked to look for the instantaneous angular velocity. Okay, this is going to lead us to calculus. Then you can go back to my previous video on differentiation. All right, so this time around I can write this. For the number 4 question, they say at t1 equals to 3 seconds and t2 equals to 6 seconds. All right, to get our instantaneous angular velocity is d theta all over dt. Okay, that is differential of theta and differentiation of time. Okay, and in the question we're given our d of theta. Our theta is everything here, which is 4 rad per second cube, then t cube all over dt. And our differentiation of time, here we are only differentiating the time. Whenever you differentiate t cube, we are going to have 3t squared. If you differentiate 2x squared, you are going to have what? 4x. You multiply the what? The coefficient with the power, and the power decreased by 1. That's differentiation. If you have like 3t cube, it's going to be 3 times 3 will give us what? 9. Then you have your t. Then if you subtract 1 from here, you are going to have what? You are going to have 2. All right, so this time around, and whenever you differentiate a variable, you have 1. So our w is going to give us differentiation. We have 4 rad per second cube. Then if you differentiate t cube, you are going to have what? 3t squared. Then all over 1. Whenever you are dividing everything by 1, you still have that same thing. Whenever you differentiate t, you have 1. Everything divided by 1, you have that same value. So this time around, at t, so at t equals to 3 seconds, so we have w, can call it w1, then equals to 4 rad all over second cube, then times 3t square. So W1 becomes 4 rad over second cube times 3 brackets 3 second square. So we give us W1 will now give us 4 rad over second cube, then times 3 times 3 square second square. So we have W1 to give us 4 rad over second cube. So we have times 3 times 9 second square. This can cancel out this. You will be left with what? Just a seconds. Our W1 is going to give us 4 times 3 times 9. 4 times 3 times 9. So it's going to give us 108. So 108 rad per seconds, because we are left with seconds here. So that's our W1. So we also look for W2. So at t equals to 6 seconds, don't forget W2 now becomes, we have to make use of this word expression, which is 4 rad over s cube, then times 3t squared. So our W2 becomes 4 rad over second cube, then times 3 bracket 6 second square. So W2 becomes 4 rad over second cube, then times 3 times 6 square, then second square. So from there, it becomes W2 then equals to 4 rad over second cube, then times 3 times 6 square is going to give us 36, then second square. This can cancel out this, will be left with what? Just a seconds. So our W2 is going to give us 4 times 3 times 36. So it's going to give us 432. So we are left with rad, our divide per, and we are left with what? Is seconds. So that is our answer. Then we can move straight to the next question.